Okay, let's give you guys some more practice. So here, find the quadratic approximation for tan of x near x equals 0, near here. Okay. So your quadratic approximation could look something like this. Okay, or it could look something like this, or whatever. Okay, find the quadratic approximation for tan of x near x equals 0. So press pause and have a go. Okay, so to do this here, start out with our quadratic. It will be in this form here, and then try and work out a, b, and c. So the first step is to put 0 into here. So when you put 0 into here, this term goes, this term here goes, leaving you c. Okay, so now we've got to put 0 into our original function. That would then give us, well, tan of 0 would be 0. So we know then we have to set this to be the same as this. So we know c here is 0. Okay, now we've got to find out a and b. So the next step is to look at the first derivative of our quadratic, and then look at the first derivative of our original function, and then set the two derivatives to be the same. Okay, so the first step here is to differentiate this and to differentiate this. So when you differentiate this here, it will give you this. Okay, it will give you this. But when you come to differentiate tan of x, it's quite tricky. So now let's try and differentiate tan of x. So when you differentiate it, it will give you this here. But let's try and differentiate tan of x. So hang on, let me jump to a different screen. So now we are going to try and differentiate tan of x. Okay, so let's differentiate tan of x. So start out with our tan of x here. Okay, so visualize it like oops, hang on, bear with me. So bear with me. Hang on, bear with me. Okay, so start out by visualizing tan of x as sine of x over cos of x, and then rewrite this as this. So now you can use the product rule. So at the moment you've got this block multiplying with this block here. So product rule, differentiate this, leave this the same. So differentiate it will give you this, leave that the same, it will give you that. And then the second part of the product rule is to leave this the same, differentiate this. So leave this the same, and then differentiate this will give you this whole thing here. Okay, so when you differentiate this here, it will give you this whole thing here. Okay, because you've got to use a combination of the product rule and the chain rule. Well, anyway, when you differentiate this, it will give you this thing here. So now tidy it up, it will give you this. It would give you this here. Okay, so when you differentiate it, it will give you this. And don't forget, this thing here is really you can visualize this thing here as this sine x over cos of x times sine x over cos of x. So that this here is just tan, this is tan, so it's really tan squared. Okay, well anyway, when you differentiate it, it will give you this here. So let's jump back to the previous screen. So we were here. Well, we've got to differentiate it. It will give us 1 plus tan squared. Okay, so differentiate this will give you this here. Now we need to so basically we started out with our quadratic, our original function here. Differentiate it, we need to set the first derivative of our quadratic to be the same as the first derivative of our original function. So we got to set this to be the same as this. Okay, at x equals 0. So put 0 into here. That will then give you b. Put 0 into here. That will give you, well, tan of 0 will be tan of 0 will be 0, and then when you square 0, so basically this block here is actually 0. So when you put 0 into here, the overall thing here will be 1. So remember, we need to set the first derivative of our quadratic to be the same as the first derivative of our original function. So these two have to be the same. So you can see that b is 1. So from earlier, c was 0, b, so c is 0, b we know is 1 now. Okay, now we've got to find out a. So we need to look at our second derivative. So now looking at our second derivative, differentiate this, it will give you this. And then now we've got to differentiate this. This is quite tricky. When you differentiate this, it will give you this. But let me jump to a second screen to show you why when you differentiate this, it will give you this. Okay, so now let me jump to a different screen. So here, here this is our first derivative here. But then, but don't forget this. We can visualize this thing here as this times this. That means it's really tan squared here. Okay, so really we want to. So this is our first derivative. Okay, jumping back to the previous screen here. The previous screen says that our first derivative is this 1 plus tan squared of x here, and we've got to differentiate this here. So now jumping back to this, look, first derivative exactly the same. Our aim here is to differentiate this. Okay, so let's try and differentiate this here. So let's just pretend at the moment. Let's just pretend that this thing here is y. Okay, so let's just, instead of using f here, let's just pretend we've got y equals this thing here. So we've got to differentiate this. Okay, so from here, let's just pretend it's y equals this thing here. So now if you operate this, if you operate this on the y, meaning if you differentiate both sides, you're in effect operating this on the y here, and then you've got to operate this on the 1, and then you've got to operate this on this block here. Well, basically you are differentiating both sides basically. So dy. So from here, dy by dx. Well, what I'm trying to say is that you can pretty much kill off this 1 here. So it's just you trying to differentiate this bit here. Okay, but then visualize this thing here as this. Okay, and then now you can use a chain rule. So when you differentiate it, this goes down. That's this 2 here, and then the bubble itself stays the same. Okay, and then the power itself here gets minus by 1, which is 1. So we can pretty much ignore that because it's to the power of 1. And then you've got to differentiate the bubble itself. So we've got to times it with the differential of the bubble itself. So from earlier, we know that when you differentiate tan, it will give you 1 plus tan squared of x. So differentiating this here will give you this. Okay, so hang on. So now you can tidy this up. So at the moment you've got this times this, and then this times this here, giving you this. So the point is that when you try and differentiate this here, blah blah blah, it will give you this. It will give you this. So now we can jump back to the previous screen and use this. Okay, hang on. So our first derivative equals this here. When you differentiate this, it will then give you this. Okay, and then put 0 into here, and then put 0 into here. So this thing here equals this, and then when you put 0 into here, this whole thing here equals 0. So now we need to set this to be the same as this, meaning that a must be 0. So looking back at our quadratic here, this here is 0, this here is 1, and this here is 0 here. So again, after all that, our quadratic approximation is really x. So it's really a straight line. So this is our quadratic approximation here. It turns out to be, our quadratic approximation turns out to be the same as our linear approximation. Okay.